Hello to the second video. We will see together today how to manage our IP plan with code using Python. We saw previously that our lab topology contains 4 core routers. For each router, we have loopback address to assign. It's a host address or /32 address. And between each two routers, we have to reserve a /30 subnet to create the interconnection between them and activate OSPF later. So let's do that with Python and see what library can we use. As an editor, I will use VS Code and I will launch a Jupyter Notebook to execute in real time and make easy the displaying of the result. So first we import our IP address library. Then we create our loopback subnet variable as a string and we assign the subnet as mentioned in our diagram. So here we can take a look. We will use 192.168.100.0 and as a mask we can use /29. It's enough for our 4 routers. Now we will use our IP address library to translate our loopback subnet from string to IPv4 network. So here I call the IP address.ipv4 and I give my loopback subnet, and here I will use hosts method to get all hosts address, and I will cast the result as a list to make easy the manipulation later. Now if I take a look to loopback hosts, I see clearly the 6 address given by my 29 subnet. Now I will create a new variable. It's hosts loopback dict. It's a dictionary variable. So here as a key I will put my router's host name, so router 1. Firstly we take none as a result, so just at the beginning I will repeat that 4 times. So router 1, next router 2 and router 3, router 4. This is my dict variable. Now I will code my for loop to assign host address to my routers. So for host in my dict variable in hosts loopback dict, hosts loopback dict host, it's equal to loopback hosts dot pop 0, which means that I will take the first value in my list and I will cast to string to get the address, the host address as a string. Now I can display my hosts loopback dict just to see the result. Okay, it's good. Now we have 4 addresses for my routers, so as mentioned in the diagram. Okay, so now let's move to the interconnection. I will do the same thing. There is a little bit changes, so I will assign to interco subnet the address of or the subnet of 10.10.10.0/24 Next, my interconnection network will be the IP address .ipv4 network. I put my interco subnet, and now I will use the method subnets, and the new prefix will be 30, which means that I will move from 24 mask to 30 mask. And of course, I have not to forget to put list just to cast the results. Now I will create a dict, and instead of to put hostname, I will put the link between routers. So the first one will be router 1 to router 2. I will use the underscore as a pattern between the two routers here. So I have router 1 to router 2, router 2 to router 3, 3 to 4, and 4 to 1. So here I will make a small change just to be in line with my diagram. So I will put router 1 to router 4. Okay, now let's move to my for loop. So for link in my interco dict. So here I will look for my host. So I will use the split with underscore pattern, and I will take the first item, which represents my host. The neighbor will be the same, but it will be the second element. For the network nets, I will take the first available subnet, so it will be interco net.pop0. The host IP, it will be the net, and here it's very useful and valuable and powerful, this IP address library. So here I will use net address +1. So here I can use mathematical operation to choose address. And the neighbor IP, it will be same expression, but I will put +2. For the mask, it's net.netmask. Okay, now I can print the result just to check what I did. So I will print the link, the host IP, the neighbor IP. I think it's enough. Okay, let's display the results. Good. So here I have 4 link, and I have the address to assign to each interfaces. So I can just check the diagram, and we can note clearly that I have the same result. So it's good.